I figure we should explain combinations and permutations since we were talking earlier about things that involved factorials. So if you don't know what a factorial is, when you see a number, any number x with an exclamation sign like this, what that means is you take the product of that number and then multiply it by one less than that number times one less than that number all the way down till you get to 2 and 1. So for example, 3 factorial is 3 times 2 times 1, or 6. Okay, so you need to know that symbol, and I'll show you how to find that on the calculator in a couple of minutes when we do these formulas for combinations and permutations. So basically what this is answering this question: how many ways can we choose a number of items out of a group of a larger number of items? So we're going to use R and N here. So the number of ways to choose R items out of N items. So something like, how many ways can I choose 3 marbles out of 10 marbles? Okay, if they were all different colors, let's say they were all different colors. How many different ways can I choose 3 out of 10? This is what these formulas answer those types of questions. Now, the difference between a combination and a permutation is when we're talking about combinations, order does not matter. So let's say we're picking from the letters A, B, C, 3 items, A, B, and C. The combination A, B, C is considered the same as the combination B, C, A. They both contain all 3 letters. So order does not matter. Here, for a permutation, the order does matter. So the combination of A, B, C would be considered a distinct permutation from the combination B, A, C, or B, C, A, or any other combination of those 3 letters. Right, so permutations, there will always be more permutations if you're using the same numbers for N and R for a combination versus a permutation. There'll always be more because here order does matter, so we're going to be counting those extra pieces or extra possibilities. So as far as formulas go, we're going to read this as the number of, for C for combination, the number of ways to choose this many items out of this many items. And this is the formula for that using the idea of factorial, which we just explained. Now again, we're not going to need to use this formula. You certainly can use this formula if you wish to, but I will show you how to find these values on the calculator very easily. But it's good to check these also to make sure we understand the formula. So they're very similar formulas. For a combination, we see this formula, the n factorial in the numerator, the difference between n and r, that factorial times the r factorial in the denominator. Notice the only difference here is we're not including that r factorial in the denominator here. And if you think about it, when we're looking at a fraction, the larger the denominator of a fraction, the smaller the overall number is, right? So if we're adding another factor in this denominator is going to be larger than this denominator. So this entire number is going to be a smaller number, which we just said is always going to be true. So as an example here, before we get to the calculator, let's say we have a group of 3 items, A, B, and C. And we want to know what is the number of combinations of 2 out of those 3. So how many ways can we choose 2 combinations out of 3 items? We'll let the 3 items be A, B, C. And because it's such a small group here, we can actually write out every different combination. Every combination of 2 out of those 3 items, well, we can take the A and the B to get one combination of 2. We can take the A and the C to get a second combination of 2. And we could take the B and the C as a third combination. Now, if we kept going, the C and the A, well, the C and the A is considered the same as A and C, right? Order does not matter. So there's only going to be 3 combinations of 2 out of these 3 items. And if we go back to the formula and put the numbers in, we'll see that we do get the number 3 here by plugging in 3 factorial, which is 3 times 2 times 1, 6. 3 minus 2 is 1. 1 factorial is just 1. And 2 factorial is 2 times 1. So we get 6 over 2, showing that we do indeed get 3 combinations of 2 items out of those 3 items. But if we look at permutations instead with the same number, how many ways can we permute 2 out of 3 of those same 3 items instead of combinations? Well, again, we can write them all out. We can say A and B, A and C, and B and C, like the 3 that we had earlier. But now B and A is distinct from A and B, because order does matter here. So the order here matters. These are 2 distinct permutations, just as CA and AC are 2 distinct permutations, and CB and BC. So we end up with 6 permutations. And again, if we use the formula, we see that we do indeed come up with the number 6. 3 factorial over 1 factorial gives us those 6 permutations. All right, so let's look at the calculator here and show you how to find these things on the calculator. All right, so here's our handy dandy calculator. So first of all, let's look and see where we find the factorial button. So we'll clear our screen here. And let's say we just want 5 factorial. So I think we go to the math button here, the math, and then over to probability. So use the arrows to move to probability, and you'll see the factorial there as the 4th choice. And notice the permutations and combinations above it. We'll use that in a second. But if we put that factorial sign, we should get 5 times 4 times 3 times 2 times 1, which, by the way, is the number of different ways to introduce the starting 5 of any basketball team, if you think about it. You got 5 choices for the first, 4 choices for the second, 3 choices for the third, and so on. So a lot of people are surprised by how large this number is. There's 120 different ways to introduce the starting 5 players on a basketball team. All right, so that is a little surprising. But that's it. So factorial, that's where you find it under math and probability. The same place we're going to find the permutations and combinations. So let's clear our screen and ask ourselves, how many combinations of, I don't know, say 3 out of 7, just for the hell of it. So when you put this in, you're going to put the total number of items first, the 7. So we're choosing 3 out of 7 here. So put the 7 in first as your first argument in the calculator, then go to the math menu in the probability section and go down to NCR for combinations, and then put the number you want out of that 7. Notice, calculator might be slightly different than this one, but it should follow somewhat closely that pattern. Put the first number in, 7, then go put the function for combinations, then put the number out of 7, hit enter, and we get our answer. So there's 35 different ways to choose 3 out of 7 when order does not matter, as we're talking about combinations. Let's do the same for permutations, and we'll see that there will be quite a bit more. So 7, again, go to the math menu, probability, down to NPR, and 3. And notice we get a whole lot more because order does matter when we're talking about permutations. 210 permutations of 3 items out of 7 items. All right, and that is pretty much combinations and permutations. Anything any number you want. You know, how many ways can we choose 11 out of 88? Sometimes the numbers will get too large and the calculator will fail on you, but let's see what we can do here. We'll use NCR since that's going to be less. So how many ways can we choose 25 out of 88, let's say? Oh man, that's a huge number. That means we're adding 21 spots to this decimal. We're moving the decimal over 21 spots. Oh, here's a good one. Let's see, how many different ways can you choose a 5-card hand from a deck of cards? So 52 cards. Now here, combination, it'll be a combination because, you know, order doesn't matter in a card hand. So we'll go over to probability, combinations, 5. So how many different combinations of 5 out of 52? So this is the number of 5-card hands possible out of a deck of cards. And there it is, 2,598,000 some different 5-card hands. All right, so combinations, permutations. This is helpful also in the previous sections we did on the binomial distribution and the geometric distribution. Good times.